Okay, a radical refers to an expression with the square root symbol. So up until now, for the most part, if you have the square root of 81, then 9 times 9 is 81, so the square root of 81 would be 9. But for this lesson, we're going to be looking more at like cubed roots or fourth roots, where, for example, for like 27, you're looking for a number that can be multiplied by itself 3 times to get 27. And that's actually the first example over here. And the way we do this, it's going to seem kind of like long and drawn out in like a complicated way, but there's a reason why we're doing it this way, because as the problems get more complicated, you can use the method. So for 27, we're going to break it up into factors. So two things that would multiply to 27 would be like 9 and 3. And then breaking up 9 into its smallest factors would be 3 and 3. So now when we look at this, we're looking at everything on the end. That's the smallest factors that this number can be broken up into. So 3 times 3 times 3 equals 27. We're looking for the cubed root, so something that can be multiplied by itself 3 times to get 27. So this is exactly what we're looking for. If we have 3 of the same number, then we can just take that out, and our answer is 3. Okay.
So basically, instead of needing 2, you now need 3 to make 1?
Correct. Or 4 if it's fourth root, and so on.
Yeah.
Okay, so number 2, we're going to repeat the same process, breaking this number up into factors. So for 125, be 5 and 25. And then breaking this up into 2 factors, 5 and 5.
How do you get that original 2 numbers?
It doesn't matter which ones you choose.
You just have to come up with one?
With 2 factors, yeah. And then, regardless of which 2 factors you choose to begin with, it'll always go down to the simplest same numbers. So here we have 5, 5, and 5, but notice this is negative. So we're going to turn these all into negatives, because negative 5 times negative 5 times negative 5 would equal negative 125. So here is our 3 numbers. And so just take that out, and our answer is negative 5.
So, how do you get the 2 negative 5s from the 25? Those are positive 5s.
So negative 5 times negative 5 would be 25.
Yeah. Are you not taking 2 positive?
Same thing. Breaking this up into factors, there's different ways you can break up 108. The way that Miss Adams did on the answer key is she did actually 4 and 27, which I thought was interesting. That's not what I had thought of.
Did you do 12 and 9?
You could probably do 12 and 9. You know your 12s. You're awesome. Anybody else know their 12s? What's that? Oh, you know.
I know 12 comes 12.
I don't know. For whatever reason, I never had to memorize my 12s. I don't know.
Yeah, I only had to memorize up to, I think it was 11s.
What's that?
I think I only had to memorize to 11s.
Yeah. I guess, for me it was 10, but 11's just kind of come naturally. Then 27, breaking that up. 9 and 3, which 9 would break up into 3 and 3. Okay, so we're taking the cubed root. We're looking for 3 of a kind to take out of the square root. So we have 3 3s. So taking that out, putting it on the outside. And then we just have 2 2's here. We're just going to multiply them and put them back inside the radical. So 2 times 2 is 4. And put it back in. And this is as much as we can do.
So if there's only 2 of one number, you just multiply
Yeah.
them?
And put them back.
You should unfactor it.
What's that?
You should unfactor it.
Yeah. Yeah. Okay. Now moving over to the next problem, number 4. Now we're doing fourth root. We're going to do the same process, but we're looking for 4 of a kind that we can take out. So 2 factors here. You could name anything. 6 and 27 is what was on the answer key, so we'll go with it. Then break up 6. At this point, I know 27 breaks up into 3 3, so I'm just going to write it like that. And we're looking for 4 of a kind, and there's 4 3s, so we can take out a 3. And then this just stays inside. Label it 4th root to be official. We're done.
We don't add the 9 because the 9 already split into the 3s, right? Like if you go.
Yeah, I just, number 5, we're learning a new process now. This one is just your basic square root. We don't normally, we would never see a 2 here because just this symbol in itself means that we're finding factors multiply by itself twice to get this number. But essentially there's like an imaginary 2 here, and we're going to be using that as part of the problem. Okay, so here's the new process. We have our x's and our y. Whatever the exponent is here, we are dividing it by the number out here, which in this case is 2. And for y, it would be 5 over 2. So this is one of the things, just go with it and it comes together in a second. So 4 divided by 2 is 2. 5 divided by 2 is 2 remainder 1. Yes, you have to use remainders. You'll see why in a second. Okay, so now what we do is these 2 numbers is what's coming out of the radical. So we have x squared and y squared that come out, and then the remainder 1 is the y that stays inside. Everybody cool with that? Okay, number 6, repeating the same process. It doesn't have a number here, so it's just regular square root with like a 2. So we get our x's and our y's. The 10 divided by 2 and 99 divided by 2. So 10 divided by 2 is 5. 9 divided by 2 is 48, remainder 1. Oh wait, 49 remainder 1, sorry. 49 remainder 1. So these guys come out. So we get x to the 5th power, y to the 49th, and remainder 1y stays in the radical.
How did you get 49 remainder 1?
99 divided by 2.
Is it 1y instead of the radical?
Let's see. 7. Okay, so now we're doing the same thing but with a cubed root. So instead of dividing by 2, we're going to be dividing by 3. So we listed out x, y, and z's. Then we'll just 15 over 3, 20 over 3, and 13 over 3. Okay. Let me take these out. Okay.
Actually, this isn't too bad.
It's not too bad. Okay, then number 8. Now we put it all together. It's just a square root, the regular with the 2. So when we break this up, we're just looking for 2 factors to take out at a time. We're going to break up this 1260. Depends on how you want to break it up. I don't know why 15 and 84. That seems so random. Like I wouldn't come up with that on my own. I'd probably say like 10 and 126. But okay, we'll go with 15 and 84. 5 and 3. 84. I don't know, maybe 2 and 42. Breaking up 42. 2 and 21. 3 and 7.
Oh, you said 42.
Yeah.
I thought you said 32, so you said 2
Mm.
and 21. Is that what you said?
Okay, so I'm just gonna focus on the number portion and then I'll go back and focus on like the variables over here. So for all these, I'm focusing on all the bottom numbers, like the smallest factors that can be broken up into, and I'm looking for things that match. So there's 2 2s, so I can take out a 2 and put it on the outside. Or there is 2 3s, so multiply by 3 and take it out. Then what's left over is the 5 and 7 that don't match. So 5 and 7 are going to go in the house, 35.
If you did different factors, would you still get?
You'd still get the same thing at the end. Did you try it? Do you want to try it? Okay, so now that I have this, now I'm going to focus on the variables here. So it's going to be for x, y, and z. Got 32 over 2, 65 over 2, and 48 over 2. Okay. So now I'm putting it all together. 2 times 3 is 6. Then I have x to the 16th, y to the 32nd power, z to the 24, square root, 35, and 1y.
What about the 2 and the 3?
What you mean?
Oh, I see.
Yeah. Okay, at this point we just repeat the same process. Yes.
Can you go back to the very end?
Okay, so now we're doing cubed root. But same process, we're going to break up the number and then we'll break up the variables. And we're looking for 3 of a kind now. For 270, 27 and 10, 5 and 2, 27. I already know that's going to break up in 3, 3, and 3. And then I'm looking for 3 of a kind, so this is 3 of a kind, so I can take a 3 out. And then the 5 times 2 is still left inside. Okay. Set these up. Divide, we get 3, remainder 1. And 7, remainder 1. So these get to come out. Number 10. So we're doing 4th root, so we're looking for 4 of a kind now. For 720, we do 10 and 72, 5 and 2, 72, I think of 8 and 9. We're looking for 4 of the same thing, and it looks like 2 repeats 4 times. So the 2 is coming out. And then what is left in? Well, you multiply 5 times 3 times 3. 5 times 3 is 15. 15 times 3 is 45, so that stays in. Then focusing on the x and the y. These come out.